Hello, and welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video, we're going to be talking about parametric polymorphism. So we've had a number of videos where we talked about inclusion polymorphism, the polymorphism that you get from inheritance and subtyping. Parametric polymorphism is a somewhat different beast, and you've seen it in a number of places before. You just didn't know it by this name. So we're going to just jump straight into some code here, and I want to show you some examples of parametric polymorphism. So one of the questions is, what does it mean to have parametric polymorphism? So I'm going to, inside of here, go ahead and create a new Scala class. Oh wait, sorry, that's not what I wanted to do. Cancel. First I want to create a new package in here. New package. I'm going to call it utility. It's tempting to call it util, but util is used by package names inside of both Scala and Java libraries, and it turns out that it creates some weird conflicts if you use that. Makes life a little bit harder. So I'm going with utility, and inside of here first I'll create a little class. And I'm kind of going to jump ahead a little bit just to show you what this can look like. I'm going to create a type called a stack. We'll be coming back and looking at what a stack is, but I want to illustrate, we're not going to write the full implementation of it. I just want to use this to illustrate the nature of parametric polymorphism. So a stack has the ability to hold items in it, and it has certain ways of accessing those items. So for example, when you put something on a stack, it's called a push, and so you would put whatever thing it is that you want to put on it, of whatever type, and push just puts it on there. Another operation is called pop, and the pop operation doesn't take any arguments, but it gives you back whatever type of thing it is that your stack holds. Some other methods that are nice to have, turns out those are really the essential ones, is empty, gives you back a boolean, and a peek operation, which doesn't change the stack, and it gives you back the top element in it. Now, I put in these question marks, which clearly Scala is not happy with because those aren't allowed in the Scala syntax. And so the question is, well, how would I write this so that in such a way that it does what I want? So the idea of a stack, along with many other collections, is that it should be able to work with pretty much anything. There really isn't much of a restriction on what I can put into a stack. However, when I create a stack, normally I create a stack of a certain thing. Now you've actually seen this exact type of functionality before, and if we bring up just a Scala REPL, you can see where you've seen this before. So for example, when we made lists, okay, this is a list of ints. Let's go with an array since it's mutable. And here we have a type parameter. Okay, so this is why I said that you've seen this before. You've seen type parameters on the list and array types. And whereas in Scala, standard value parameters are put inside of parentheses, type parameters are always put inside of square brackets. So if you're passing values to something, you will have parentheses. If you're passing types to something, you will have square brackets. Now I said that we want, so what can you make an array of? Well, you should be able to make an array of anything, and that's basically what this type parameter allows you to do. But you almost never want an array that has lots of different things in it at the same time. So for example, you generally don't want to store inside of here a string. Okay. Now if that worked, we would have gotten the array 1 high 3. Which there are certain situations where you might want that, but it's very rare. And because it's so rare, generally you want the language to enforce the type that you've picked, because it makes it more useful. What are the operations that you can do with integers and with strings? And turns out the answer is there's not much you can do with both of those. If you only have ints, though, there's a whole set of mathematical operations you can do. If you only have strings, you have the whole set of taking substrings and getting characters in it and all the other things that are feasible to do with strings. But if you have a combination of them, when you pull something out of the array, you don't know what it is, and so it's very hard to decide what you can do with it. So the idea of the parametric polymorphism is you want to work with multiple types, but we want to put some restrictions on what type is in any given instance. And so how do we represent that in our code? As I said, this is something we'll come back to because we're going to do this a lot as we write our own collections. The array and the list are written for us, but we're going to expand on that quite a bit in the second half of the book. So just like the syntax here indicates, I put some square brackets after the type, so array and then brackets int. When I write this code, I am going to say, okay, this is a class, it's called stack, and it takes a type parameter of A. So when you make a stack, you're supposed to tell it what type A you want. And then of course I could have parentheses with whatever other arguments that were value arguments I wanted inside of there. Stack doesn't need it, but you can pass in multiple type arguments as well. And it's just a comma-separated list the way you might expect. So this type A, now when we create a stack, we would say that I want a stack of ints, or I want a stack of doubles, or a stack of strings. So when you push something onto this, the type that you're pushing is the type A, and the type that you're popping is the type A, and the type that you're peeking is the type A. And now we have an error, which from the previous videos you should be able to identify. It says that the stack needs to be abstract because I have not defined any of these, and that is exactly what I want to do. In fact, it's quite possible instead of calling this a stack, I might call it a trait instead, because it's going to be completely abstract. Okay, so this was just to introduce the syntax of how you can attach type parameters onto classes and then how you can use them. So inside of this scope here, just like if I passed in some normal arguments, those arguments would live inside of this scope and I could use them as values. When I pass in type parameters, this becomes a type that exists inside of this scope, and so I can use the name A as my type. It is standard style in Scala to use single capital letters for your type parameters. You could argue that that isn't really all that expressive. However, because generally the type parameters don't really, and so what does A represent here? Well, it's whatever type of element you want in your stack. So it doesn't really need to have a good name in this situation. And if you use anything that's not a single capital letter, there's a chance that you're hiding a type from the outside. And so that's something, the reason for using the single capital letters is so that you don't hide outside names. There shouldn't be anything in your code where you create a class named A. So this A shouldn't be hiding anything from you. And if you do create a class named A somewhere else in your code, you deserve whatever misfortune falls upon you for doing so. So this is a simple example of how we could put this on a class. And as I said, we'll come back and we'll see a lot more of this. The other thing that I want to show you, though, is how we can also attach type parameters not just to classes, but also to functions or methods. So I'm going to create an object, and I'm going to call it sorts. Okay? And that probably tells you exactly the type of thing that I'm going to put inside of here. I want to add some sorts into this code. And in the part 1 of the book, we saw several different types of sorts. We'll see some more this semester. In this case, I don't care about having a good sort. I just want to demonstrate polymorphism in the sorts. And so I'm perfectly happy going with the simplest of sorts, a bubble sort. And to start off with, I'll pass in an array of int. And so the bubble sort works in place. It's supposed to rearrange the elements of that array into sorted order, and we can write this sort fairly quickly. 0 until a dot length minus 1 for j in 0 until a dot length minus 1 minus I. If a sub j plus 1 is less than a sub j, then I need to do a swap. So val temp equals a sub j equals a sub j plus 1, a sub j plus 1 equals temp. Okay, so there's a little bubble sort. We can stick a main inside of here. Def main args is an array of string, and I can make myself a little array. Val, let's call it nums, equals array dot fill. Let's just make 20 numbers, and util.random.next int of 100. By the way, this right here is exactly where, if I had called this package util instead of utility, I would have had problems. Doing it possibly not in this package, but if I were writing code like this in other packages, that's where I would run into problems. And so we can print out, let's print out nums.mk string with some spacing in between them. Then let's bubble sort nums and print them back out. Okay, so I just have 20 numbers here. I just want to do this to make certain that our bubble sort actually works. We have numbers in random order to start with, and after the sort, they're all in proper order. Okay. What really matters to me, though, is not the sort itself, but right now the current limitations on the sort and how we get around those. So the current limitation that we have on this sort is that this sort works with ints. And what would I have to do if I wanted to sort something other than ints? Let's say I wanted to sort doubles. Well, I could take and, I could copy the whole code and paste it, but really all I have to make is one change. Boom, now this works on doubles. Okay. Doesn't work down here because this is an array of ints. But you know, that's all that was needed. String, boom. Now that bubble sort sorts strings. But if I wanted to have a bubble sort for ints and doubles and strings, my program needed to sort all three of them. That would mean I'd need 3 copies of the bubble sort, and that is really inefficient. I don't want to have to do that. It should be possible to do some type of parametric or some type of polymorphism here, and indeed, this is a perfect case of where I want to do parametric polymorphism. I can take my bubble sort, and I can say, okay, the bubble sort sorts a type A, and you pass in an array of A. Now, as you can see, this introduces an error. And the problem with this right here is actually that when you have type A as a parameter like this, Scala has to assume that this is the most general type possible. This could be anything. And literally that means that A, it has to assume that A is kind of equivalent to the type any. And type any does not have a less than method in it. Okay? So you're not allowed to do this here. How can we get around that? Well, there are 2 ways to get around that I want to show you. The first of which is to set a type bound. So instead of saying that array can be just anything, I can place bounds. Or instead of saying that A can be just anything, I can place bounds on it. And in this case, the bound that I want is to say that A is a subtype of, well, something that has a less than. And it turns out that there is a nice trait in the library called ordered. And this right here says that bubble sort will work with any A as long as A happens to be a subtype of ordered of A. Okay. And because of that, you'll notice this works again. Ordered of A has a less than in it. So any type that fulfills this requirement will work in this code right here. However, there's an error down here, and you might wonder what's the problem. And what this error basically says is that int does not satisfy the requirement of being a subtype of ordered A. It turns out that the int type does not inherit from ordered A. And that might seem like a bit of a limitation to you. However, at least at this level, we can't do anything to fix it. We didn't write int. We can't change the code that is in int. We're stuck with however it is implemented. The fast way around this is we're going to change this by one character, and it changes the meaning just a bit. So the less than followed by a colon says you are the type is a subtype of something else. The colon and a percent sign says that you can be a subtype of it, or there can be an implicit conversion from your type to something else that is a subtype. Now that's, in some ways, implicit conversions are a more advanced topic. We don't really touch on them much in this book, but it just so happens that because ints are ordered, there is an implicit ordering from, or there is an implicit conversion from int to ordered of int. And so that means that this sort works just fine. And we can run it, and you can see that our sort is still perfectly happy and functional. And the advantage here is that I can now use this one sort, and if I change this so that it is just math.random, which generates doubles, so now my nums is an array of double, not an array of int. And this code still works. Okay, because this sort will work with anything that can be converted to ordered. And ints can be converted to ordered, and doubles can be converted to ordered, and strings can be converted to ordered. And it turns out that if you were to learn more about implicit conversions, you can write your own implicits to make it so that things that you want have this same implicit conversion. I have to be honest, this is not my preferred way of making the bubble sort general. We'll come back in the next video and I'll show you how I like to do my bubble sorts. This is something that we'll use multiple times through the semester. I like this other way because it's fundamentally more flexible than this, and we'll talk about that more in the next video.